Hello everyone, this is Dr. Marrero from Math Topics. Welcome to today's video. Welcome to the series, How Do I Teach Math? How Do I Learn Math? If you have never visited our channel, give us 5 minutes and then you decide. Don't forget that we have a lot of playlists and this is one of the most beautiful ones. How do I teach math and how do I learn math? Teaching math with rigor is one of the challenges in today's school. And I always try to find ways to increase the rigor in class because this is part of the mathematical foundation and the intellectual foundation that every student learning mathematics or every person learning mathematics needs. Proof. Proof is something that is pretty much absent from our classrooms. We teach curriculums, we teach content, we teach theorems, we teach characteristics, relations, but we don't have enough proof in our classroom. And when the student finish all the K through 12 curriculums and move to college, is when the student start seeing proof and they start struggling with proof. And one of the causes is that we do not have too many proof in our curriculum. I teach high school mathematics, and I know that geometry, another subject that I teach, contains a lot of proof. In the mathematics curriculum in geometry 10th grade, we have plenty of proof. But beside that, in algebra 1, in algebra 2, pre-calc, we do not have enough proof. And I think, and I want to hear your opinion, that we need to increase that ability because it's a training of the mind. It's a training. And as soon as you expose the students to that area of the mathematics that is called the proof, you will start seeing results. I'm not talking about big proof or complicated proof. We are talking about something like this proposition that you're seeing right now. There does not exist a largest natural number. It's a simple proposition and it's a simple proof. But with the simple proposition and the simple proof, we can start. This is the beginning of the training of the mind to prove. And students, they don't have idea how powerful is this, because when you prove, you motivate the student. It's not only saying, but it's only demonstrating why. And this is powerful in terms of engagement, and this is powerful in terms of motivation. We can say that the sum of the angles in a triangle is equal to 180. But if we prove it with the two lines parallel, and we arrived at that conclusion, you have a different sense of accomplishment, a very different sense, a very different feeling of accomplishment. And you will never forget that the sum of the angles in a triangle is equal to 180. You will never forget that because you know how to prove it. So my recommendation for this series, How Do I Teach and How Do I Learn Math, is to increase the number of proof in a classroom. Simple propositions like this one. We can use it as a warm-up in a classroom. The warm-up is the first section of the classroom. And the students come to the class, the bell rings, and you put right there on the board. Can you prove this? Does not exist a largest natural number. At the same time, you can teach number sense. At the same time, you can teach natural numbers. And at the same time, you can teach infinity. Because if we prove this, that doesn't exist, a largest natural numbers, we're talking about infinity. And it's not only now to say natural numbers we have infinite natural numbers. So look at the difference between saying something that is really abstract, like infinite numbers, and something that you're going to prove right now. There doesn't exist a largest natural number. What do you think? If you teach natural number, you teach infinite natural numbers, and you are also able to prove it. Let's do it now. So imagine that you are teaching an elementary school student, just that, elementary school student. We are not to put any grade level, just elementary school. They know the natural numbers. They know there are 1, 2, 3, the counting numbers. And also, one of the main characteristics that you discuss in class and that you provide to the students is that we have infinite amount of numbers. How can we move the conversation further? Proving that proposition. You can say to your students, this is a proposition, but let's do it from a mathematical perspective. Of course, it's a conversation that you can have in middle school. It's a conversation that you can have in high school. So let's say this. We are going to use something or a technique that is really important. The technique is saying the opposite. We know that number that is the largest natural number. And the student's going to say, can we do that? Yes. So let's say that the number n is the largest natural number in the world. That's it. That number belongs to the natural number system. This is the symbol for natural number system. So we're not talking about that. We are not talking about notation. We're proving. N is our largest natural number and belongs to a natural number. By assumption, n plus 1 is also a natural number. Because 5 is a natural number and 5 plus 1 is 6 is another natural number. So we are assuming that because it's a characteristic of a natural number system. So n is a natural number. N plus 1 is also a natural number. Okay? So we can say now that n, our largest natural number, because we decide that, is greater, yes, is greater than or equal n plus 1. We have an inequality right there, beautiful inequality. So I'm going to start the conversation again. We are going to prove by contradiction that there does not exist a largest natural number. So we're going to say the opposite. It's a technique the students need to know. So let's pick n is a natural number. N plus 1 is also a natural number. But we are saying that n is the largest natural number. So n is greater than or equal n plus 1. Because I decide that n is the largest natural number. If we work on this inequality now, we move the students to the inequality solutions and we eliminate n on both sides of the inequality by subtracting n on both sides. We have here 0. We have here 0 is greater than or equal 1, and this is a false statement. This is a false statement, yes or no? Yes, teacher. It's a false statement because 0 is no greater than 1. So what I was saying at the beginning, that n is our largest natural number, is false. So our assumption is false. So we have proved that there doesn't exist a largest natural number. This simplicity in teaching mathematics is going to create better learners in every subject. It's not only in science, not only in mathematics. A very simple proof using natural number. Using the first number that everyone say, the counting numbers, 1, 2, 3, 4. Look at how many things are here. Number sense, number system, the idea of infinite numbers, and the technique to prove something. We say the opposite and we arrive at a contradiction, and then what we said, what we were assuming, is false. The largest natural number does not exist. I hope you like the video. And don't forget to join Math Topics membership. It's very powerful. I can tell you that. It's very powerful. I update it every week. I put extra resources for you to enjoy and to learn mathematics. If you like the video, don't forget to share. Don't forget to give us a like. Don't forget to be part of Math Topics. Thank you. See you in the next video.